But in the industry, these few are named as the main raw materials. What? Sodium chloride. It is concentrated sodium chloride solution. We call it brine solution. It's limestone to get carbon dioxide there. Then students, it's ammonia. Also we use there as a raw material. Then there's this process. Which process? Solvay process. It follows mainly 4 steps. It's a 4-step process. What are the 4 steps that you would be following? They are during this Solvay process. There students, if you could find the step 1, right, and step 2, step 3 and step 4 are the 4 steps followed there during this process. Step 1 is the ammonification. So we are going to talk about the ammonification at the very first. Then it is the second step for the second next. So it is carbonization. The step number 2. Then it's when we follow the carbonization step, it's we pass carbon dioxide, we dissolve carbon dioxide through in that solution we get after ammonification, after saturation of that concentrated sodium chloride solution. In the ammonification step, what we do is we blow ammonia inside that sodium chloride, concentrated sodium chloride, as to dissolve ammonia inside this solution. Ammonia is a very soluble gas. So if we dissolve ammonia in this concentrated NaCl solution, we make it saturated with ammonia. So if we then at the end of the first step, if we get the concentrated NaCl solution saturated with ammonia, is what we get as the product after first step. Ammonification is that we saturate the concentrated NaCl solution with ammonia. Then students, it's then secondly we pass that in the carbonization tower. If we use 2 towers, so it's then we pass carbon dioxide gas through this solution that we have got after the first step. Then it is a basic solution you get. Carbon dioxide's water solubility is not that high, but carbon dioxide is an acidic gas. So therefore, this acidic gas could dissolve more in basic solution that we prepare there in the step 1. So it is actually a trick we follow there in step 1, making it more basic with ammonia, as we could then we could enhance its water solubility of carbon dioxide. Secondly, when you pass carbon dioxide as to dissolve that inside that solution, it aids this ammonia basic substance, it aids dissolution of carbon dioxide there. So during these 2 steps, first 2 steps, in each step you would expect a dissolution of gas inside the solution. So students, hope you know this fact. Gases, they do not have intermolecular attraction forces. When those gases get dissolved inside solutions, they form intermolecular attraction forces, or they form compounds there, new chemical compounds. So they form bonding there. Bond formation is exothermic, bond dissociation is endothermic. Therefore students, if you would expect these first 2 steps, dissolution of gases, they are in solutions, being exothermic processes. Then when you have these exothermic processes being done there in first 2 steps, the temperature would get increased with the heat it releases out. So it's quite a disadvantageous thing. Because at high temperatures, the dissolution of gases would be less for the reason gases dissolutions is exothermic. Therefore, at lower temperatures, you could dissolve more and more gases in water. Therefore, students, those places we carry out those first two steps, we need to cool. We need to keep the places cool continuously. You need to focus on that as well. You need to maintain those two towers that you pass ammonia for the first time as well as carbon dioxide at the next time. You need to keep it cold. You need to cool those two towers. Then students, at the end of the second process, it's after dissolution of carbon dioxide, it's automatically sodium bicarbonate would start precipitating. So then in the solution that you get, you have solid sodium bicarbonate being formed. I will be explaining how and why is that this sodium bicarbonate is formed there. For the reason sodium bicarbonate is quite water soluble substance. So this is highly water soluble, but under these conditions that you provide, it precipitates there. So after treating it with carbon dioxide, the solution from the step 1, so after second step, it starts precipitation of sodium bicarbonate. So we'll find it out how and why. So students, you need to separate that sodium bicarbonate next. It is the separation of sodium bicarbonate from sodium bicarbonate precipitate, solid sodium bicarbonate. You could simply filter that. So there are some methodical approaches as you could separate that sodium bicarbonate. Okay, it's next the separated sodium bicarbonate. So it could contain some ammonium chloride as well in it as impurities. Then students, if you need to heat that, to form sodium carbonate, formation of sodium carbonate. So that's how we manufacture sodium carbonate using our 4 steps. So it's you need to heat that sodium bicarbonate. Decomposition of sodium bicarbonate gives you sodium carbonate, carbon dioxide and water vapor. So it's you get sodium carbonate. So it's then you could follow further purification steps as well. There, students, you would get a byproduct, ammonium chloride. This ammonium chloride byproduct could be used as to reform ammonia. We could reform ammonia there. So we could recover that ammonia at the very first we feed here inside the first tower. We could recover that ammonia there at the end from the final solution left behind. There in the dissociation of calcium carbonate is done to collect or to produce carbon dioxide there. That carbon dioxide is the carbon dioxide there we use in the step 2. Then the byproduct left behind there is calcium oxide. If you could treat it with water as form calcium hydroxide, or you could straightly use calcium oxide form. Then if you could treat the final solution with that calcium oxide or hydroxide. It's a basic substance. So all the ammonium cation, ammonium salt, ammonium cation, NH4 plus cation containing substances, solutions would liberate ammonia in the presence of a base. That's the concept, that's the idea, that's the principle. There are students, if you would recover ammonia, then when you treat that final solution with calcium oxide or calcium hydroxide, it would start liberating, giving ammonia back. You would collect that ammonia. Theoretically, it's the same ammonia amount, but in practice, it's very trace amount you could lose, but it's you could recover most of it, ammonia being used there. Okay, students, those are the 4 steps being followed during Which process? During the solving process. Okay, then let's find them out in more details, having reactions as well. Students, these 4 steps, especially these first 2 steps, would be followed inside the 2 towers. We could call them twin towers. If we are using twin towers, let's find them out. The twin towers that we use follow the first step, then after second step. This is one of those towers. So at the top, from the top, if we pass our solution, raw material solution. What's the raw material solution we have? It's the concentrated brine solution we feed. Concentrated brine solution, NaCl. It is the brine solution we feed. Brine solution contains concentrated NaCl in it. It's pure NaCl, concentrated NaCl. We add at the top of the tower 1. This is the tower 1. Is where we do the ammonification. So to ammonify, you need ammonia. You need to feed ammonia at the bottom. So if you pass ammonia gas there from the bottom side, so ammonia gas, it's a gas, therefore it goes up. Then this is a solution, it's heavy, it falls down. Then we let them meet each other. That means we let ammonia to touch the solution with each other. It is at opposite 2 directions we pass those 2 streams. So when we do such a thing, it's called counter current principle. Our students, if we follow the counter current principle as to make that sure the dissolution of ammonia gas inside this solution is done well. Okay, so then it's one word we have, it is this solution would be heavy, so would be fallen down fast. To slower that, if we maintain, or if we have some porous plates, we have some porous plates made out of clay. It is some clay plates, perforated clay plates we have. So we could call them baffles. It is, students, we have some perforated plates, clay plates. So at the bottom, it collects the solution, the final solution. So what's the final solution is having now? It's having still concentrated NaCl. So it was not harmed. This concentrated NaCl is still there. So you could take concentrated NaCl containing that solution. So it is now you have concentrated NaCl. But it's not only concentrated NaCl, it is you have passed ammonia gas through that. Ammonia gas is a well-soluble gas. It is well-soluble in water. Even soluble in well water. Okay, so this ammonia gas would get dissolved inside this solution. So this solution, concentrated NaCl solution, which comes down. So then it is the counter current method. So you blow ammonia gas up. Then this ammonia would get dissolved. This solution would be saturated with ammonia. It's possible some ammonia to left behind. So you collect that ammonia. It's the used ammonia then. So you then take that ammonia and pass back. So you could recycle that. Then students, if you get a concentrated NaCl solution which has saturated with what? It has saturated with what else? Ammonia. So it's the very first step. At the very first step, you would have this reaction being done. Students, it is NH3 dissolving in water. You would get, this is liquid, you would get its ammonium hydroxide, which is the weak base aqueous being formed. It is you have not only concentrated NaCl now they are in the solution, but also ammonium hydroxide they are in the solution. If we use this solution they are means at the top of the second tower. You have another tower as well. Students, it is concentrated NaCl solution with ammonium hydroxide saturated with ammonia. If we then send through the second tower, it's at the top of the second tower, we feed that solution from the top. Students, they are also to avoid falling it down fast. We have some baffles. It's perforated clay plates we have. They are so some baffles we use inside the tower. It is the second tower. This is the ammonification step. This is the carbonization step. So it is we blow carbon dioxide gas, CO2 gas at the bottom of the second tower. So the solution would be fallen down under gravity. This is a gas would be going up, touching that solution. It's again the counter current method, counter current principle is applied. Okay, then students, you would find that out this carbon dioxide going up, touching it well and dissolving it in it. So then used CO2 you would collect there, and you would then after reuse that, means it is remaining CO2, it is the used CO2 in the waste you get, so you would reuse, right? So and you would pass it back here. How would you get carbon dioxide? Students, carbon dioxide is obtained by the thermal decomposition of limestone. It's calcium carbonate. If you could do this inside a kiln furnace. So, students, it's calcium carbonate is subjected to the thermal decomposition into calcium oxide, which is a solid, is a byproduct you get there, and carbon dioxide gas. That carbon dioxide gas is the one you pass here at the bottom. Okay. Then students, carbon dioxide, its water solubility is not that good. It's quite poor, its water solubility. Carbon dioxide gas will get dissolved into water, giving you carbonic acid, H2CO3. It's very weak compared to ammonia solubility. It's very low, the solubility of carbon dioxide. Then this carbonic acid by its first dissociation gives H plus and bicarbonate anions, HCO3 minus anions there. Okay. Then students, this H plus would be used up by the OH minus from the weak base NH4OH. Therefore, according to the Lechatelier's principle, when this H plus is removed from the medium, reacting with OH minus from NH4OH forming water, then the forward direction would follow would be more favored. Therefore, students, it's there when you pass carbon dioxide gas there, we could expect this reaction to proceed. It is ammonium hydroxide you have what? Ammonium hydroxide you have what? Would combine, I will give it here using this space. Ammonium hydroxide you have what? Would combine with carbon dioxide, giving you ammonium bicarbonate, because it is you have ammonium plus NH4 plus after leaving of OH minus to react with this H plus, you have NH4 plus only there, and after leaving of this H plus, it is more and more HCO3 minus. HCO3 minus concentration would get increased there. Therefore, it gives you ammonium bicarbonate. Students, then these are just to explain you what is having there. If you would straightly give this as was the reaction there when you pass carbon dioxide there at the bottom of the second cover what you are having. So it's you would collect the second solution at the bottom. Now the second solution there that you collect at the bottom is having these all things being done. What are being done there? So students, it's a way. If you have ammonium bicarbonate, with that there is an increased concentration of bicarbonate. It is a high concentration of bicarbonate you get. Then at the very beginning it was a bright solution you fed at the top of the first tower. It was there a high concentration of Na+. Students, the concentration of bicarbonate after this reaction is very high, as well as the concentration of Na+ also is very high from the very beginning. Therefore, normally they do not form precipitates. They are well soluble. All the bicarbonates, all the stable bicarbonates are well soluble in water. But under these circumstances, as it is a high concentration of HCO3 minus and it's a very high concentration of Na+. Therefore, these high concentrations, super concentrations of Na+ and HCO3 minus let them to form precipitates. It is you get NaHCO3 precipitate being formed. Is what it's having. Is what Ernest Solvay used there in his process. Is the most important thing that you get there. So NaHCO3 is precipitated. Normally it's not precipitated under normal conditions, but this very high concentrations of Na+ as well as HCO3 minus make them to form precipitates of NaHCO3. Students, I could give you that reaction in a way like this. It is the most important. So it is this NaCl with NH4 HCO3 gives you NaHCO3. It is a precipitate solid, and NH4Cl is what you get there. These are aqueous. So you could then have here in the solution, if you have solid precipitate of NaHCO3, then the step 2 is done. So these are the twin towers. This is the place where the ammonification is done. This is the place where the carbonization is done. So, as I have mentioned, in both of these towers, what you mainly get dissolution of gases inside the solution inside water. Students, to encourage this dissolution with dissolution of the gases in water, it is exothermic. Therefore, heat would be liberated. Therefore, these temperatures would get increased. They are in both towers. Therefore, it's required to continuously cool these towers. It is you would cover this tower with a cooling jacket. It's a water cooling system. Water circulating cooling system you could supply there. So around both towers. So students, it's then you could keep it cool continuously. Okay, that's how we maintain conditions. Then it's again at the top of the first tower, it is concentrated NaCl brine. We provide there. So we feed ammonia there. So the first product, that solution it consists of concentrated NaCl saturated with ammonia. That concentrated NaCl, when it gets saturated with ammonia, it is ammonium hydroxide. You could expect there inside the solution. So that ammonium hydroxide containing solution with concentrated NaCl, we feed it there at the top of the first tower. When you feed it at the top of the first towel, you will be providing carbon dioxide gas at the bottom of the it is at the second tower, right? At the top of the second tower, when you feed this concentrated NaCl saturated with ammonia, we pass carbon dioxide as to react with each. So you would get this reaction being done forming ammonium bicarbonate. Bicarbonate solution, bicarbonate ion concentration inside the solution would get increased. It is increased. So with the high concentration of Na plus, then a precipitate of sodium bicarbonate is formed. It is NaCl with NH4HCO3 forms NaHCO3 precipitate with NH4Cl. This NH4Cl still seems as a byproduct. Okay, so we'll talk about that later on. So those students are the first two steps that you will be following. Then in the next step, what's the next step? Is the separation of sodium bicarbonate. Is the step number 3. In the step number 3, we are going to collect that formed precipitate. We could filter it. Simply we could filter it. If you collect that sodium bicarbonate, then students, it's this sodium bicarbonate. Normally sodium bicarbonate is called baking soda. So this sodium bicarbonate is still having that ammonium chloride in it. Therefore, it's possible to have that smell of ammonia there. So therefore, it needs some purifications, even as baking soda. You can't use this sodium bicarbonate straightly as the baking soda. Students, what we do next is we next heat this sodium bicarbonate form as to decompose that. It's more space, therefore I'm going to erase this. So students, in your third step, you would be heating the formed sodium bicarbonate solid as to decompose that into sodium carbonate. How do you know the fact that all the bicarbonates first decompose into their respective carbonates? So it gives you sodium carbonate solid, carbon dioxide gas and water vapor. So you heat it hard as to get sodium carbonate. Then when you balance this reaction, you will find 2 there. Then students, you would heat it hard as to get sodium carbonate. After separation of sodium bicarbonate is the fourth step. You heat that hard as to get sodium carbonate. Then you would follow further steps as to manufacture baking soda. How is that? Students, you could manufacture baking soda as you dissolve this sodium carbonate solid in water. When you dissolve that in water, you will get aqueous sodium carbonate. So this aqueous sodium carbonate, you saturate water with sodium carbonate. Then after you pass this aqueous sodium carbonate with inside that you pass carbon dioxide. You treat that aqueous sodium carbonate with what? Carbon dioxide gas. And with water it reacts, it forms sodium bicarbonate. Is how you would manufacture. Then you could reprecipitate this sodium bicarbonate. Sodium bicarbonate is the baking soda. You could use this in baking as the baking soda in for baking purposes. They are in foods. So as cooking breads, those buns, such. Then students, you could manufacture baking powder with this baking soda. How? It is either sodium or potassium nitrate. You could mix with tartaric acid with this sodium bicarbonate as to manufacture baking powder. Then students, further, you could use this sodium bicarbonate as to you could use this in fire extinguishers, the sodium bicarbonate. Then those are the applications that you could find with sodium bicarbonates. Then students, it's here you get carbon dioxide. This amount of carbon dioxide, you could use this again. They are in the second tower. You could resend this carbon dioxide in second tower. Then it is not totally carbon dioxide recovered. It is part of carbon dioxide. That carbon is still there here. But you would recover part of carbon dioxide there. So then it is in second tower. It's you manufacture carbon dioxide by heating limestones in a kiln, or we could call it an oven. So there you could use fuel. It is you would be using fuel. Then it is the combustion of those fuel also gives you carbon dioxide. That carbon dioxide also you could use in this process. It's normally they mix those limestones with coal in 13:1 mass ratio, and they burn it, they heat it. Then it gives a mixture with 40% of carbon dioxide in it. That mixture is the gas mixture that they send to the second tower normally in the industrial process. Anyway, here the carbon dioxide you get, you would reuse it in the tower number 2, second tower. Then students, another thing, you have got ammonium chloride being formed as a byproduct. That byproduct, ammonium chloride, could be treated with, it's aqueous, so could be treated with calcium oxide form there. Students, you are going to have ammonia gas and calcium chloride and its water, you could expect its water. Then it is, you could expect it's 2 here and it's then balanced. It's 2 here. Students, all the ammonia that you have used, theoretically you could recover. You could reform that ammonia as to reuse there again at the first tower. At the bottom of the first tower, you could resend this. But in application, it's possible to lose some ammonia. So then you need to take some ammonia further. So anyway, then it is finally you could see that I gave you the idea of Leblanc process. There you had some pollutants as HCl vapor, HCl fume. Then you got calcium sulfide. So those pollutants you got. But students, you don't get pollutants. The only byproduct here form is calcium chloride. This calcium chloride, you could use it as a desiccant. It's highly hygroscopic. So you could use it as a desiccant, as well as you could use this with the mother solution or bittern solution after extraction of salt in solvents using seawater. Then the remaining solution would contain sulfates, chlorides, bromide, those ions. When you treat this calcium chloride with the bittern solution, you could form calcium sulfate precipitate. It's nothing else but gypsum. So students, you could use this to manufacture gypsum. It is important in cement industry. We identify it as plaster of Paris as well. Okay. So therefore, it is very less here that you could expect the pollution. Environmental pollution is very less. It is one important thing. It's very important, right? Then students, when you check for the raw materials, you are not using sulfuric acid, concentrated sulfuric acid. So we are using sodium chloride and its ammonia we could recover. Therefore, ammonia, you can't say it's used up there during the process. Theoretically, we could recover all the ammonia back. Therefore, ammonia it's not continuous expense that you need to have there for ammonia. So there is no such continual expense standing for ammonia. So it's sodium chloride and it's limestone. Compared to that lead process, these two are not expensive as much as of concentrated sulfuric acid you use. Therefore, these are cheap raw materials. These are cheap raw materials you get. They are in solvay process. Then students, it's you could reuse, recover this carbon dioxide. You could reuse that, and it's ammonia also you could reuse. Therefore, this process makes it easily and environmental friendly and lowering the production cost. It promises manufacturing of sodium carbonate there. Students, after introduction of this process, it is when it was about 1880s, the prominent sodium carbonate manufacturing process in 1880 around was lead process. But after introduction of this solvay process, when it started being used, it replaced that process, that method of manufacturing sodium carbonate using lead process. When it was about 1900, so students, it was this process, the major process was being used as the major process to manufacture sodium carbonate, solvay process. Then when it was 1922, this that lead process, it was the final plant, manufacturing plant of sodium carbonate using lead process closed in 1922. Thereon, it is solvay process only we are using to manufacture sodium carbonate. It is the solvay process. But students, as I have mentioned earlier, in Wyoming, in USA, like North America, it's in 1938, they discovered a sodium carbonate containing ore. It contains sodium carbonate as well as sodium carbonate, sodium bicarbonate containing minerals there. Then they found it out, using of those minerals was more advantageous or was more cheaper than of using this process to manufacture sodium carbonate. Therefore, they are still using their minerals got by mining those. So their minerals on manufacturing of sodium carbonate. But it is 30% only. So the contribution of those sodium carbonate to the total global amount product of sodium carbonate in all over the world. It is 70% of sodium carbonate still manufactured using this process. Okay students, hope you could understand these few simple things. Isn't it simple? Right? Okay, so with the hope as to meet you again with another industry, which we are going to round up here in this video. Okay students, goodbye.